Today my topic of discussion is inverse of matrix. Inverse of matrix. So can you tell me what is the criteria that a matrix inverse must exist? What is the criteria that the matrix inverse must exist? If we have a matrix, capital A, okay, let us consider a square matrix. First of all, we need to check whether the matrix, the corresponding determinant is non-singular or not. So first of all, there is a checking criteria. Checking criteria is given a matrix A, given a matrix A, check whether determinant of A, or sometimes we call it, we write it as det A, whether it is not equal to 0 or not, or whether the matrix is non-singular. For singular matrix, for singular matrix, inverse does not exist. Okay, so this is the checking criteria. Now, once this is satisfied, suppose this criteria is satisfied, then what we do, we can call this checking criteria to be our step number 1. In step number 2, what we do is we find the adjoint of the matrix. Adjoint of the matrix. Okay, and this is denoted by adjoint of A, which is actually the transpose of the matrix of the cofactors. Cofactors. Okay. And step number 3 is the inverse is defined as 1 by det A adjoint of A. So this is the criteria by which we consider, we try to find out the inverse of a given matrix. Okay. A very small example we can take into consideration. Suppose we have a square matrix capital A, which is given by, say for example, 1, 2, then we have 2 minus 1. Suppose this is my matrix. So first of all, if I want to apply the step number 1, we need to check whether determinant of A is 0 or not. Okay. For determinant of A equal to 0, the matrix A is singular, and hence inverse will not exist. Will not exist. So if I try to find out the determinant of this particular matrix, we know already the determinant is a function which, when applied on the matrix taken from the set, it gives me a real number. So with this, we can find the determinant to be which is equal to -5, which is not equal to 0. And therefore, our conclusion is A inverse exists. So checking criteria is done. Next, what we do, we try to find, we shall find the cofactors of each element of the matrix. Each element of the matrix, and we will construct the matrix of cofactors. Matrix of cofactors. Okay, so let's try to do it. We have the matrix A 1 2 2 minus 1. So cofactor of 1 I am going to calculate. Cofactor of 2 I am going to calculate. Cofactor of 2, another 2 is there, I'm going to calculate, and cofactor of -1 I'm going to calculate. And we know by definition that cofactor is calculated in the following manner. As for example, in this particular matrix, the order of the matrix is 2 by 2. So this particular 1, if I want to find the cofactor of this element 1, what we do, we first check in which particular cell the 1 exists. The number 1 exists in the cell 1, row 1 and column 1. So what we do, we consider -1 to the power 1 plus 1. The first number is corresponding to the row, and the second number corresponding to column. And we do not consider in which this 1 is existing. We do not consider this row and column in which the 1 is appearing. And what we write? We write the minor of 1. Okay. Then this implies this is equal to -1 to the power 2. -1 to the power 2 is 1. So this element is positive, and we simply get minor of 1. Minor of 1 means the element, we do not consider the cell, the row and the column in which the element whose cofactor is I'm supposed to find. I am considering this element. This -1 becomes your minor of this one. Okay, so my cofactor of 1 thus becomes simply -1. Similarly, if you want to find the cofactor of 2, I'm taking this 2. Then what we write? The number 2 is appearing in the first row, second column, and then we are writing the minor of 2, and this is equal to -1 to the power 3. That is some minus sign will be there, which will precede the minor, and that will be minor of 2. And minor of 2 is simply, you do not consider the column and the row in which 2 appears. So the minor of 2 here is 2. This is the minor of that 2. Okay, so we have got this. Second, we consider the cofactor of this one. This is appearing in the second row, first column, and we are going to calculate the minor of these 2. This element is also negative. It will precede the minor of 2, and this minor of 2 will be this particular element 2. You do not consider the row and the column in which this 2 appears. Okay, so this is also 2. And the last one is -1, which appears in the second row in the second column. And we are going to calculate minor of -1. And this is equal to this element will become positive. And we are going to simply calculate minor of -1. Okay. And this minor of -1 is this element, that is 1. So we have calculated all the cofactors of each and every element present in the given square matrix. Now, at this point, we will try to construct the matrix of cofactors. Okay. So what we do is that we simply write the matrix of its order 2 by 2, and in place of the elements we will put their cofactors. So the cofactor of 1 is -1, so we are putting here -1. Cofactor of 2 is 2, we are putting here 2. Cofactor of 2 is 2, we are putting here 2. Cofactor of -1 is 1, we are putting here 1. So this is my matrix of cofactor. This is not my adjoint. Okay. Let's go to the next page. And there I'm going to apply step number 3. So adjoint of A is equal to the transpose of matrix of cofactors. Okay. So we have the matrix this -1, 2, 2, 1. We are putting here -1, 2, 2, 1. And we are going to take the transpose. And this becomes -1, 2, 2, 1. Okay. So this is the thing. We have got our adjoint of A. Lastly, we are going to calculate that we are going to find the inverse of the matrix, which is 1 by det A adjoint of A. 1 by det A means 1 by -5. And just put the matrix that you have got, the adjoint of A, and we get -1 by 5, 2 by -2 by 5, -2 by 5, and 1 by 5. So this is your inverse. Why it is inverse? Probably you have, this is a kind of recapitulation that I have done. Probably you have learned inverse in your school days. But why this? How can I say that this is going to be the inverse of the matrix? Is it, is my calculation all right? There is a thing that you can do with that. So what we can do now, you can consider your original matrix, which is 1, 2, 2, -1. Someone raised his hand. Unmute yourself and ask.
Hello, sir. It's Arif.
Yes.
Sir, can you show me the previous slide, please?
Yes.
Sir, the cofactor of 2, you have written 2, but I think that will be -2.
Yes,
Oh,
sir.
yeah. Which one? Yeah. Sure. Yes. Negative 2.
Cofactor
Both
of 2, both
yes,
one.
yes,
Both
both.
one.
Yes.
Thank you.
-2. Yes. Thank you so much. So this cofactorial will be -2. This will be -2, and this thing will be positive sign will not be there. I mean, minus sign will not be there. So that will be 2 by 5 and 2 by 5. Now it is all right. So now if what you are going to do is that you are going to take the original matrix and the inverse. You are going to multiply this. So my original matrix was 1, 2, 2, -1. My original matrix was 1, 2, 2, -1. And my inverse is -1 by 5, 2 by 5, 2 by 5, and 1 by 5. And you are going to multiply these two. if we multiply, you know the matrix multiplication, how it is done. Still, I'm showing this to you because it is a prerequisite class. So that's why I am showing it in details. So this is the way by which the matrices are multiplied. Obviously, there is a rule that we must all follow before we go for matrix multiplication. You know very well that the rule is number of columns of the first matrix must be equal to the number of rows of the second matrix. If it is not satisfied, you cannot multiply the two matrices. Remember, the matrix multiplication is not commutative. So we have got, I think, no, one more mistake is there. Yes, one more mistake is there that I have to rectify, because here the determinant was -5. So this element will be +1/5 and this element will be -1/5. Okay, so I missed the minus signs. So this will be +1/5 and this will be -1/5. So this will be +1/5, 1 into 1/5 plus 2 into 2/5, and that will be 1 into 2/5 plus 2 into -1/5. Sorry, minus sign will be there. This one will be 2 into 1/5 plus and -1 into 2/5, and that will be 2 into 2/5, and that will be -1 into -1/5. Now it is all right. So that will be 1/5 plus 4/5. This will be 2/5 minus 2/5. This will be plus 2/5 minus 2/5, and that will be 4/5 plus 1/5. And what do we get? We get 1, 0, 0, 1. Now what's happening? And if you do the reverse, you can easily show that A inverse, if you multiply A by A inverse from the left hand side, you will see the same result will come. This matrix that I have got here is called the identity matrix. Identity matrix of M2 cross 2 F. You know what M2 cross 2 F is, because I have discussed this in the previous class. This matrix will serve as the identity element, additive identity element. Sorry, not additive identity, multiplicative identity element of the matrix. Okay. Now, what is this? What is the? I mean, why do I so much care about finding the matrix inverse? What have we actually found? When we learned the number system, we always were interested, after learning the multiplication, you always were interested in finding a number corresponding to any number A, such that if we multiply this number by that number X, this number is unknown to us, we hopefully, with the by the law of the field, we want the we want the number itself. Okay, so we call this type of number X is called the multiplicative identity. You already know it. This is called multiplicative identity. Okay, someone has raised his hand once again. Polo.
Sir, please show the first page.
First page. Yeah, this is
Yes,
the
sir.
first page. This is the first page. I am saving the pages. I will later send you. You will get it. Okay. I'm saving the
Okay,
pages.
sir.
Yeah. Okay. So multiplicative identity, which we actually denote by 1, and once we get the multiplicative identity, then we can easily say that, yeah, 1 is a number which, when multiplied by the non-unity numbers, we get the number itself. A into 1 gives you A. This type of multiplicative identities are actually very important, and are always interested in finding the multiplicative identities for the sets where multiplication is defined. Now, if it is a matter of a numbered system, then we all know that one will serve the purpose. But right now we are not dealing with the number system. We are actually dealing with the we are dealing with the set, which is, for simplicity, I'm writing it as M2 cross 2F. This set I am actually concerned about. This set is the set of all 2 by 2 matrices over the field F. Okay. Now this set doesn't contain numbers. So it is quite obvious that we'll not be able to we will not be able to say that number 1 is the multiplicative identity of this element, because you see that if a particular person takes the if I write the matrix 1 2 2 minus 1, suppose I'm writing it here 1 2 2 minus 1, and if someone says okay multiplicative identity is 1, then he is wrong, because this is not the case. Actually, this is not the multiplicative identity. What is this? It is called the scalar multiplication. It is actually it is not the identity element. It is not serving the purpose, because multiplicative identity will be nothing but is nothing different from it. It doesn't come out from outside the set. Multiplicative identity is a number which is one of the numbers present in the set, and it is a special type of number which serves the purpose. Matrix doesn't contain, the set of matrices doesn't contain numbers. So a particular number cannot be the multiplicative identity of the set. And therefore, if we want to find the multiplicative identity of the set of matrices, 2 by 2 matrices, we definitely know that this multiplicative identity will be of a matrix type. Okay. Now, when we actually consider a general matrix of the form A11, A12, A21, A22 of this type, and suppose we do not have the formula with us, then what am I supposed to do? How to find? At least we know that we want to get the multiplicative identity as 0 1 0 1 0 0 1, and we are interested in finding a matrix which, when multiplied by the given matrix, will give us the multiplicative identity. You know that that matrix is called the multiplicative inverse, because 2 into 1 is equal to 2. We all know that. But 1 is the multiplicative identity, but 2 multiplied by half gives you 1. So half becomes the multiplicative inverse of 2, and which, when multiplied by the 2, gives you the multiplicative identity. So this is the multiplicative inverse of 2, multiplicative inverse of 2, and this is the multiplicative identity of the set under consideration. Multiplicative identity of the set under consideration. So we are interested in finding a number which gives you, which when multiplied with the given matrix, this is my given matrix, these numbers, all these numbers are known to us, and these numbers are not known to us. These are unknown numbers. Okay, these numbers are not known to us. These are unknown numbers. So we want to find a kind of, we want to find out the numbers A11 prime, A12 prime, A21 prime, and 22 prime. What we are going to do? We are going to simply multiply this particular matrices. So we will write A11 into A11 prime plus A12 into A21 prime. Here we are going to write A11, A12 prime plus A12 into A22 prime. Here we are going to write A21 into A11 prime plus A22 into A21 prime, and A21 into A12 prime plus A22 into A22 prime. And this is equal to 1 0 0 1. And now you know that when the two matrices are equal, their individual elements are equal. If I'm saying that this matrix is equal to that matrix, means this part is equal to this part is equal to 0, this part is equal to 0 and this part is equal to this. So we are going to equate, we are going to get equations like a11 into a11 prime, a12 into a21 prime, which will be equal to 1, a11 into a12 prime plus a12 into a22 prime, which is equal to 0, a21 into a11 prime plus a22 into a21 prime, which is equal to 0, a21 into a12 prime plus a22 into a12 prime, which is equal to 1. And our objective is to solve these two equations. I solve these 4 equations. Okay. So if you solve this equation, if you solve this equation, if you solve this equation for the unknowns, a11 prime, a12 prime, a21 prime, a22 prime, if you do this, you are going to get, I'm leaving this solving purpose for you to do by yourself. Okay, because it can be easily done, because there are 4 equations and 4 unknowns. You can easily do it. It's kind of abstract solution will come. We will see that a11 prime will nothing but equal to the, will be equal to, if you solve it, you will find that this will nothing but be equal to a22, which is the cofactor of a11. If you solve it and you find, if you try to find out a12 prime, you will see that it will be equal to a21 minus, which is the cofactor of a12, and so on and so on. So by looking into this, and not only this, a determinant term will also be there. A particular term, I'm not writing the term, it is large. A particular term will be there divided by the particular term. And if you carefully observe that the term will be same for each and every element, if you carefully observe, you will find that this term is nothing but the determinant of the given matrix, a11, a21, a11, a12, a21, a22. Okay, so by this particular small calculation, they have found a particular general methodology by which the matrix inverse can be found. So this is the logic, this is the maths, this is the mathematics that actually been done, the mathematics that I have shown in this particular page. This simple equation, this set of equations were solved, and out of this, a particular general criteria were designed by which any matrix inverse, if exists, can be found. My objective was to show that mathematics can be read in 2 different ways. We can read the applications of the mathematics. We can write the how to apply algorithms to different mathematical problems. Or since you are doing the higher mathematics, you are actually working with space, fields, etc. You have to know that what is happening inside, because how the thing is being actually, the things are coming. How do we have to think about the abstraction? This abstraction is not taught in school. This abstraction is taught in college. So this is the abstraction, the thing which you are now seeing in front of you, in front of the screen. That is the abstraction. Out from this abstraction, the general criteria were designed by which we can easily find the matrix, the inverse of the matrices. The problem is that now if I consider this matrix, the matrix was what? 1, 2, 2 minus 1. Okay. Two questions that I'm posing in front of you. 2 questions that I'm asking. You don't have to reply it. First question is that number 1, why matrix inverse is required? Why matrix inverse is required? Probably you know this answer. I mean, a matrix is there. I want to find the inverse. Why is it so? Yeah, okay, we have understood the mathematics that this is how the matrix inverse is found. This is the meaning of the matrix inverse, why it is required. Simple answer to this question is to solve system of equation, to solve system of equation. Okay, so suppose we have a system like this. X plus 2y is equal to 3 and 2x plus y is equal to 4, and we want to find the equation, the solution of the given system. Then either you can apply the general algebraic method by which this can be easily solved because there are two equations, two unknowns, or you can give it a matrix form and you can solve it. What we do is that from this we try to write the coefficient matrix 1 2 2 1. Okay, and we can multiply this by the column matrix xy. Here the number of columns of this matrix is equal to the number of rows of that matrix, so matrix multiplication can be done, and we can equate this to the right hand side matrix, which is 3 4. And actually I have given this a form which is Ax equal to b. Now if A inverse exists, then we can multiply both the sides by A inverse. Okay, we can multiply both the sides by A inverse. And you know the matrix multiplication is associative. We already know this. So we can associate the first two matrices. And you know that A inverse and A gives you the identity matrix. So we can write it as Ix is equal to A inverse B, which implies X equal to A inverse B. So if we find the matrix inverse, we can multiply this matrix inverse by the right hand side matrix to get the solution of the system. This is my question number. This is my question. First question, that was my reply. My second question is something else that I'm not going to ask. I'm going to ask in the second session because this session is going to end very soon. Time countdown has already begun. So if I start explaining the thing, I'll not be able to finish it. So let us pose this question and try to find out its answer in the second session. So I'm